the girls basketball.
Like it was like it was basically just like stop.
So they broke it up around the line. The local,
And I always
you know, like,
we did this game.
it's fun. All right, so today I just have a few more terms for you, and we're gonna finish up the notes here, just about 2 or 3 slides, that's it. And then I will post the study guide for you and your vocab assignment. So you can just attach your vocab after today, and then you can work on studying. Speaking tomorrow review, and then that's on Monday. I have a test on Monday. It is what it is. Huh? Is it? I think the other one was just start of the second one. General. What's up?
I know.
Go over the review. Like study guide?
Yeah.
Okay.
Excuse the interruption, but we are aware that there is an issue with Sapphire and attendance. Until that is corrected, could you please either email me the students that are not here, or have a student bring it up on a piece of paper, whichever is easiest for you. We'll let you know once this issue has been corrected. Thank you.
Anybody want to make an adventure?
Why?
Nope, just email it. So zip it. Work on the bell ringer. Yeah.
All right, so yesterday we talked about a few key people of the scientific revolution, looking more at anatomy. So who do we talk about? Who do we talk about? Chris, go ahead, give me one.
Andreas Vesalius.
Yeah, good job, Andreas Vesalius. Good, good. So he mentioned a lot about the anatomy of the body. He's known as the father of predicting the anatomy of the body. So before this, okay, ancient Rome and Greece, they understood the muscles, the organs by dissecting animals, right? And we know that isn't really an accurate description of the anatomy of the body since they're doing it in animals. But later, okay, when the scientific revolution was about, Vesalius dissected human body, right? So they're dead bodies, but in any case, he had an accurate description and accurate model of what the body looks like because he dissected human bodies. So before this scientific revolution, what was thought to be pumping the blood through the body? What organ? Man, the liver. Jeez, imagine that. Wow. All right, and then after obviously these findings, we know that the heart does it. Okay, good job, good job. So Vesalius, you can just put by his name, right? That he is the father of finding the anatomy of the body, of depicting the anatomy of the body. All right, who else did we talk about? Who else? Connor.
William Harvey.
Yeah, William Harvey, good job. And what is he known?
He published a book on motion of blood.
Good, good. So the circulatory system, good. So he was depicting about the heart, right? He was trying to understand how blood flows through the body. And he realized with arteries and veins, okay, how with arteries, the blood flows away from the heart, okay, it's more oxidative because it got pumped to the rest of the body. And then veins, okay, this is obviously pushing the blood back to the heart, okay, low oxygen. So it needs to be pumped for more oxygen to really push throughout the body. All right, so again, he did so by really breaking down the body, okay, even really looking at dissecting the human body and really understanding veins and arteries and how the heart works. So he's detailed and noting about the circulatory system. Good. All right, did we talk about Robert Boyle yesterday? I don't think we did. All right, so what do we know about him? He was on one of your vocab terms. One of your vocab terms. Anybody? Anybody have? All right, Chris, go ahead.
Developed scientific method.
Okay, yeah, good job. So we'll talk more about here, Francis Bacon here, and really detailing about the scientific method. Boyle also described what? Go ahead, Ozzy. Okay, all right. So he's known as one of the fathers of chemistry. Okay, he also depicted more with volume and pressure. So with a higher volume, what happens to pressure? Let's say you have a container, and the volume is a little bit bigger, right? What happens to the pressure? Go ahead, Paul. So higher volume, let's say you're putting in a larger, let's say, what happens to the pressure? The pressure. So let's say you have air pressure, right? So you put it in volume, you increase the volume. What happens to the pressure? It'll go down. Good job. Let's say you decrease the volume. What happens to the pressure? It'll go up. Good. 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 So I know it's pretty simple, pretty basic, but at the time this was groundbreaking, right? This is something that's never been understood before. Okay. Do you guys know if you shake a can of soda and you turn it, set it down and turn it clockwise 3 times, it doesn't spray out anywhere? It actually dissolves the pressure, it actually pushes dispersive pressure to the side. You guys should try it out.
I'm going to be very.
I know. Pretty crazy. Do it. Do it.
Will you do it?
I'll do it. Do it. Let's see it. Not right now.
Did you do all this?
I did it over the weekend. I promise it works. I was like, oh wow, okay, let's just try it out.
You can just tap on the side.
So I was like, this is perfect. And what we're just talking about, volume pressure. So I was like, oh, well, let's try it out.
And then the camera tap on the side.
No, look at that. All right, so there you go. You guys can try that out on your own. Just put your face real close to the top of the nose. But no, I'm serious. It doesn't explode. I promise. All right. Okay. So yesterday we talked about a few of those key figures of the scientific revolution. You'll need to know them on the test. Okay. Again, you'll find it on the study guide. But I want to make sure that we discuss those people, especially when it comes to the anatomy of the body. All right. Now I'm going to move towards the scientific revolution here. Well, the scientific method.
So I have a few more terms and that's it. This is going to finish them up for this chapter. So once you're done, I will have the assignment out. And all you have to do is just post it. There you go. Got Antoine Lavoisier. Francis Bacon. Yummy. Bacon. And then we have the scientific method. Do another minute? Okay, one more minute.
Let's go.
Sure, I can see what you point out.
Yeah.
You should sit down. Just listening to what you're saying. Simon says, sit down, get up. Oh, I lost if it was Simon says.
All right. Then you was the sign call and you know like past 2 days, but then you come in today. Now all YouTube just disrupted. All right, Antoine Lavizouet, what do we have? This way I'm trying to pronounce it as best I can. Antoine Lavizouet. Yeah. We have. Come on. It's a study guide right away here. Really, I think. What's that? Yeah, good job. So he really founded and thinks about oxygen, okay, detailing about it, later being applied to the periodic table, and he's known as the father of chemistry. Make sure you guys put that down. The father of chemistry. And he detailed about how oxygen is included here with it combustion. Right? So when you're blowing things up, hopefully you're not doing any of that. Right? Okay, Francis Bacon. Not here. Chop it up to bacon. Doesn't
We
want
don't
it up.
have a bacon.
Maybe. Go ahead, Connor. Yeah, good job. So he's detailed about the scientific method, inductive reasoning. Okay, so that we need to try to question the world around us and come up with conclusions based off of our experimentation, going and formulating a hypothesis and running through this scientific method of experimentation to try to prove our hypothesis. Okay, if not, well, then we have to go back and try to formulate a new hypothesis. And the whole time, we need to try to exclude any type of biases, any type of maybe any type of conclusions that might come to our mind where we actually don't run through the scientific method. We need to be aware of bounding variables. So variables that could skew our results, skew our data. Okay, so this whole time through the scientific method is crucial and important that we have a basis of a step-by-step procedure to follow through with finding new ideas and principles through science. All right, so the scientific method, you'll learn about it quite a bit in science class, I'm sure. If you take psychology, we talk about it quite a bit too. So, all right, so the scientific method, just talked about it. Where do we start? So you first have to do what? Ask a question, right?
No.
No?
Yeah. Wait, no.
What do you do, Chris? Ask a question, okay, then you do what? You make an observation.
Oh, that's after? Oh, okay.
All right, so then you make an observation, right? So then where do you go? What? You make an observation, then you do what? Create a what? What? You have a hypothesis, good. Hypothesis, usually in mid-density, this includes your independent variable. Anybody know what an independent variable is? Connor? Yeah, good job. So this is a variable that's controlled by the experiment. That's altered by the experiment. All right. So this is something that's altered by the experimenter. It just depends on obviously what you're studying. Dependent variable. What is that? Dependent variable. Amelia. Yeah, good job. So this is like the measure, right? The measurement. This is the outcome, right? This is something that is detailed with this possible measurement. It's changed, it's altered by the independent variable. All right, good. And then where do you go? So you formulate a hypothesis. How do you try to prove this hypothesis? Go ahead, Lana. Okay. Yeah, you go through the experiment. Good. So as you're going through the experiment, you're realizing, yeah, you want this maybe going according to plan, maybe not. So you have to do what? You have to look at your results. Right? So once you look at your results, you can look at your hypothesis. If it's correct, what do? You publish your results, right? Well, first you want to replicate it, make sure that there's no confounding variables. So you gotta go through the process again, even if it's correct, even if it's wrong. Right? So if it's wrong, you go back up to the hypothesis, try to formulate a new one that might fit. Obviously, your experiment. Okay, if it's correct, again, you should replicate the study, right? Just to make sure there's no confounding variables that's causing any differences or problems to your results. And once you're done, you publish it, right? Here it is, good. There is my results. I want you to step-by-step process of the scientific method. Okay, all right. So real quick, I just want to go through 2 slides, that's it. Talking about Francis Bacon here and the scientific method, and then I'll get you working on your study guide. What do you think, 3 minutes? No? Yeah? Alana? What's that?
Just say yes, a lot of you say.
Yeah.
Conversation.
Huh? You complaining over there?
Yes.
Yeah, okay.
Yes, I am.
I got you on recording here. All right, so here, Francis Bacon, scientific method. Wasn't much of a scientist himself, but he realized that we need to have a step-by-step process of trying to prove the world around us. We just can't follow through of what this Catholic Church is telling us. Okay, in other words, we need to try to prove and find insight and understand through reasoning, through accounts, through reports, why running through a scientific method. So there needs to be a step-by-step process of proving the world around us. Okay, remember with Galileo, what happened to him? Was he questioned heavily by the Catholic Church? Yeah, he was. Right? Yeah, he was. He was viewed as a heretic, someone that was directly challenging the church's rule, the church's power. Okay, and with that, to make sure that we don't have these issues anymore, we need to make sure we can prove our findings through experimentation. Okay, and to follow through a step-by-step process so that there is no doubt, that there is no issues when it comes to concerns of how the world works. So we mentioned quite a bit about these key figures of the scientific revolution, and they need ideas that are backed. Right? They need proof. They need facts to express their opinions and principles of the world and of the sciences that they're focused on. And the way to do that is through a scientific method. Again, Galileo is kind of grilled out by the Catholic Church to a point where he said, I'm not going to ever speak out about them again. Right? I'm never going to talk about these new principles of science that challenge the church's authority. And to make sure that we can avoid this in the future, we need to make sure we have a step-by-step process. Okay, the scientific method. So with inductive reasoning, okay, this is really just making sure that you eliminate all bias from whatever you're studying. Okay, you need to make sure that you can question the world around us and try to prove those questions. Okay, so you need to start somewhere. You ask a question, you make observations, right? You formulate a hypothesis. You run the experiment. Okay, you replicate the study if it goes according to plan to make sure there's no confounding variables. And if it goes through, perfect. You can report your results. You can report your conclusion here, right? If not, right, if you go through the experiment and you see that your hypothesis is incorrect, you got to go right back to the start and begin again. Right? You got to start over, formulate a hypothesis that is a little bit more of a reason. All right, so inductive reasoning, you're questioning, you're trying to find a conclusion. With deductive reasoning, it's more just you have the conclusion and you just are there, right? You have the statement, you have the understanding, okay? And you're just really following through with that statement. But with inductive reasoning, we're understanding the world by questioning, by observation, by experimentation, running through the scientific method. And this is what's going to drive new innovations and inventions moving forward. So when we talk about this new industrial age that's coming here soon enough, yeah, this is going to really be built up, especially for warfare, right? When we get to World War I and World War II, and even before that, with means of transportation, okay, this is all stemming from the scientific revolution. All right, so again, with your scientific process here, okay, this is just basic, right? I'll just have you do these 5 steps. If you take more of a psychology class, there's more to it, but in any case, I just want to make sure you have the 5 steps here. So number 1 here, you make an observation, you observe the natural event. Okay, you ask a question usually before that, but in any case, you have an observable event done. Number 2, you formulate a hypothesis. So an if-then statement, right? If this occurs, then this will be the result. And you have an independent variable that is altered or changed by the experimenter, the dependent variable, which is usually the measurement here, that is the conclusion from what you change with the independent variable. And then you test the hypothesis. So perform an organized experiment to test the theory. So once you do that, again, there's more steps to it, but I'll just have it in a more 5-step process. You replicate the study. So you want to make sure there's no confounding variables, right? So once you finish up, you prove your hypothesis. Usually you replicate it to make sure there's nothing altering or skewing your data. All right, number 4 is analyze the results from the test. Again, usually replicate it there. If it's right, you can conclude it, right? And then number 5, you can just report your results. Or if it's wrong, you go back up and change your hypothesis. Run through the experiment again. And this is just a continuation. All right, is there any questions here? Scientific method? No. All right, so for Sir Francis Bacon, again, proving this, remember all the hardships that Galileo faced when he was questioned by the church. Well, we need to make sure that we can prove our results. We need to make sure that we can have facts to back our principles, our understandings, our studies. So this is where the scientific method comes about and changing the world forever. All right, so that is the notes there. That's it. So we will have the test on Monday. Here's your study guide. And here's the vocab. So the vocab should be already finished. All you got to do is just turn it in. Just publish that. And then the study guide right here. So I'll click on it, show you real quick. I should have a Quizlet being made at some point today. I'll put up the Quizlet for you, and then I'll adapt it to be a booklet. All right. I think Ms. O'Neill's working on it right now. She should be done with it soon. So that should be up on the study guide post. So when you guys check it out later, if you want to play a booklet or Quizlet, that will be attached here to the study guide. So next time you click on the assignment, there it should be there. But if not, let me know, and I'll make sure I have those links for you to help you with studying, to help you with the understanding of it. I like you guys to answer in red font, all right, font color. That'd be great. Sometimes when I'm reading through it, you just kind of attach it to the question. And so it's like, where is this done? Is it not? Well, anyway, just try to do it in a different font color. Red would be the best. If you want to do blue, whatever, but I would prefer red. All right, so here is the study guide. I think there's 41 questions. Yep, 41. So don't miss the one here on the next page. Okay? All right, you guys want some music while you work? Yeah? Look at that, more than 3 minutes. Not bad. Not bad. About what? I don't know, 9? 10? Not terrible. Close to 10?